Okay, we are now going to look at addressing modes, which is one very important concept of instruction representation. So this is again another way of classifying instructions based on the address. So in an instruction, we saw that you have a number of bits for the operation code, which tells you what operation is going to be performed, and then we have a number of bits for the address of the operand, right? So based on what that address bits signify, there are some 5-6 ways of classifying instructions. That is what we mean when we say addressing modes. And why do you need such a lot of addressing modes? To give flexibility to the user. So sometimes you might know exactly the location where the data is present. So let's say I have a variable x, its memory location is 1001. Sometimes you might know this 1001. Sometimes you might not know the exact location, but you might know the location of the location, the double pointer analogy. So depending upon what you know, you should be able to achieve what you want. So knowing or not knowing something related to the location of the variable, related to the address, should not be an obstacle to your being able to accomplish the code you've written. So that is one of the main reasons we have multiple modes. Secondly, to use the bits in the address field efficiently. So in computer memory, there are billions of locations, so the number of bits required will also be more. So in such cases, there are certain addressing modes which help you represent this address more effectively. So for example, if you have a memory location and the address itself is 20 bits long, you will need 20 plus some x bits to store that instruction itself. So if your instructions itself are taking up a lot of space, and then your data is going to take up even more space, your memory is going to become full very soon. So if you can shrink that 20-bit instruction into some 10 bits or even 15 bits, you're going to be saving some space. That can be accomplished with the help of some addressing modes. And then to improve efficiency and to overcome limitations. So basically, you're trying to optimize the available resources of hardware, space, time, and so on. That is the motivation behind having different addressing modes. So we will now look at the different types of addressing modes. The first is implied mode. So the address of the operands are implicitly specified. So this is what refers to your 0 address instructions and 1 address instructions. So in a 0 address instruction, when I simply say push or pop, it is implied that I am talking about the stack register. In a 1 address instruction, when I say add x, my x is the source and it is implied that my destination is the accumulator register. So I am not explicitly giving the address of the operand, it is implicitly understood. So that is what we mean by implied mode. The second is immediate mode. So instead of specifying the address of the operand itself is specified. So as in, instead of doing a equals 5, b equals 10, add a plus b, you're directly giving add 5 plus 10. So you directly give the number or the value itself. That is immediate mode. The third addressing mode is register mode. So this is your normal direct addressing where you have your opcode followed by address. But the address refers to a register. It is not a main memory address. So all that your system needs to do is go to that location within the register itself, pick up the data and start working on it. That is register mode. Next one is register indirect mode, which is like your indirect addressing which we studied yesterday. It's like a address of the address, the double pointer thing. But again, it refers to register addresses. So your instruction has an opcode and then a register address. So if you go to that register, you will find another register address. You go to the second address, here you will find your value. So your data is still in a register and the address given to you is also a register address, but you have to go to the address of the address to find your data. That is register indirect mode. Next, within register indirect mode, we have a subtype which is auto increment or auto decrement. So when the address in the register is used to access the memory, the value in the register is incremented or decremented by 1 automatically. Meaning, let us say you have an instruction which has opcode followed by 1010. Assume 1010 here is a register address. You go to 1010, there you find the second register address which is 1050. So you go to 1050 and you find your data which is a number, let's say 10. You take the 10 and then you do addition, subtraction, whatever. This is your register indirect mode. Now what happens in register indirect mode with auto increment is you go to 1010, you find that 1050. As soon as you access that 1050, the contents of 1010 get incremented by 1. So that 1050 becomes 1051. So the next time you come to that location, it will lead you to the next bit or the next piece of data. Similarly, in auto decrement, it gets decremented by 1. So the idea is it still works the same way a double pointer does. It still works on registers and not on the main memory, but your second pointer, which is where you start tracing back the location, it automatically updates its contents to point to the next register or the subsequent register after every time you've accessed it. And why does it do this? So let us say you want to access two pieces of data, 1050 and 1051. Now for 1050 your second pointer is 1010. Again for 1051 you need another second pointer, let's say 1011. So at this point you are using 4 different memory locations. But if you use this auto increment or decrement mode, the same 1010 can be used to first point to 1050, then to 51, 52, 53 and so on. So you are so in this case I gave the example of 4 pointers, and then that 1011 alone is not necessary, so it becomes 3. But as the number of bits you need keeps increasing, and if they are all sequential bits, using one pointer you can access an entire sequence, an entire list of bits. So that is going to cut down greatly on the amount of space you require to store pointers and so on, right? So that is what we have auto increment and auto decrement for.